our moon is more than just a shimmering light in the night sky. It also serves as a timekeeper. For example, the moon takes 29.5 days to orbit the Earth, which is the basis for our month. In fact, the word month is even derived from the word moon. During its orbit around Earth, the moon goes through 4 main lunar phases. Each phase is visible for about 1 week, and the moon's appearance differs from phase to phase. The different appearances are a result of the position of the moon's orbit in relation to where the sun and the Earth are. The moon's first phase is called new moon, though we cannot actually see it at this point. That's because positionally the moon is between the sun and the Earth, which means we're viewing the dark side of the moon against the equally dark night sky. Nevertheless, by the following week, the moon is into its second phase, called first quarter moon, or half moon. By week 3, it's in its third and brightest phase, called full moon. This is when the moon is on the side of the Earth opposite the sun, and it's during this phase that a lunar eclipse can occur. By the 4th week, the moon comes into its final phase, called last quarter or third quarter moon, and it has the same half-moon appearance as it did in phase 2. The moon then returns back to its first phase to start anew. The orbit of the moon is like clockwork. It's never late and never early. This powerful timepiece is not only the basis for the month, but also for the lunar calendar. In addition to the lunar calendar, we also have the solar calendar. The solar calendar is based off of the time it takes for the Earth to orbit around the sun one time. Interestingly, every day for some 200 years now, astronomers in Greenwich have noted the position of the sun using a special solar telescope. When the sun passes directly overhead, it is exactly noon Greenwich Mean Time, also known as Universal Time or Zulu Time, and all clocks in the world are synced to this clock. Of course, not only can the sun and moon be used to keep time, but so can the stars. Just like the sun, the stars rise in the east and set in the west. As soon as a star rises, it takes about 6 hours to reach its highest point, and another 6 hours to set. Although the stars are consistent, the rotation of the Earth around the sun changes our perspective of the stars from night to night, which affects the position and rise time of the star. For example, the same star viewed on one night at a certain time would on the next night be shifted slightly to the west and would rise approximately 4 minutes earlier. Significantly, after 1 year, the perspective of the stars would be back to their original positions. Truly, the sun, moon, and stars are a testimony to the words of Genesis 1:14, where God establishes them as timekeepers.